there's an exact replica in the digital world. Unexposed film is an you have a camera box, typically you have that, some kind of a lens to form an image. In the back of an analog camera, you have some film moving past an open slot. The opposite of a focal plane shutter. Now the slot is still, the film moves. And here would be the exposed material. Well, in the digital world, unexposed film, unused disk shapes. Well, what is this? Well, it's a linear array. It's a bunch of pixels stacked on top of each other. And what about this? Well, that's used up film. That means it's used disk space. So the analogy is quite accurate. In the case of film, you move it. In the case of a digital, you sample that array periodically. And so now let's take a look at what happens when you put an image on either the array or the slot of the camera. Such as this. It might be a fluorescent tube, a piece of board painted white or something, a lamp. So there it sits. The only thing that happens at this point is this area of this image falls on the sensor. And if this happens from the time that you turn the camera on, either with film or in the digital one, in that case you could imagine, well, what kind of a result am I going to get? Well, if that's there all the time, in that case you get one horizontal streak. It's not that much use to you except, well, first of all, you can't tell what it really was. And the other is that it just says, well, I had some exposure, some effect over there for all the time that the camera was running. So that way it's not very useful. But suppose that instead of having that object there or the image there all the time, and you start your camera running. And after a while you say, oh, okay, well, I'll turn that light on. It's a light. And later on you change your mind, you turn it off. And now you end up with a result that looks sort of like this. You still don't know what it is by looking at the result. But you can tell something about the subject. Typically what you know is how fast your recording rate is going on. So then you say, well, supposing that this is moving, we should accommodate our South African friends and call this in centimeters. Yeah, centimeters per second or inches per second. In any case, suppose it's inches per second, and this is moving at an inch a second, and you measure the length of this streak, and it's 2 inches. Well, you can tell, well, that lamp was on for 2 seconds. Right? So now you have, what you have is a stopwatch here. You get better time resolution, you move this faster. That's sort of the basic principle. But this way you can time all kinds of things, and you get a record. You don't have to listen to somebody who says, well, I timed it with a stopwatch. You can publish this. You just put the timing in, out it comes. But suppose that image, instead of standing still like it did here, it moves. So it's here at some point, here later, and here later. And suppose this is a continuous motion from bottom to top. What do you expect the result to look like? Yeah, I noticed. Somebody said, a diagonal line. Yeah, well, that's it. So if the recording rate now is uniform, and the motion upward is uniform, then you get a straight line. The slope of that line tells you how fast this object was moving. If you knew what the scale was, how far did it travel? But if you're working with an image, in that case you can easily figure out what the image speed was. You may not know what the subject speed is, but the connection between images and subjects is governed by what? Magnification, right? What the difference is between the image size and the object size. So all you need to know is, I photographed a 100-foot thing and I reduced it to 1 foot. Magnification is 1/100. So how do you figure out how fast the image is traveling? Well, the image exists in a particular place. Well, at the image plane. In this case, it interacts with film, which is, I know, is, how wide is 35 millimeter film? Anybody know?
It's less than 35.
Oh, less than 30. 35 millimeter film is 35 millimeters wide. That's why they call it 35 millimeter film. I've won a lot of bets in bars that way,
How many people think the image is 35?
Yeah, well, yeah, exactly. So, but we know that, this distance, right? So now we need to know, well, the object was here at the bottom of the film at some time. It was at the top at some other time. We measure the distance from here to here. Let's say it's, again, 2 inches. the image moved 35 millimeters in 2 inches, so in 2 seconds, because it's an inch a second, so in 2 seconds it moved 35 millimeters, 17.5 millimeters per second. That was the rate at which this thing was moving. We know the image speed. And we say, well, how many times bigger was the object than the image? And it's not hard to figure out. And you multiply that, out comes subject velocity. Pretty neat. And if the velocity changes, in that case, I think you can predict you're going to get some kind of a curved line, right? Now, one of these tells you that the image is traveling faster. And which one? The one on the right? Now, this tells you that the image is actually traveling as it moves up. It's moving up. That's right. This is slower. The closer you get to horizontal, the more it goes to 0, right? So this is speeding up, and this is slowing down. When it needs up, you get a graph of velocity over. Data reduction becomes almost automatic. You just got to put in the scales. That's all. But suppose that the subject, instead of moving all the way across the film, does something like this. It vibrates in place. Vibration studies are right for being examined with a street camera. So you put the vibrating subject over here. What do you expect the result to look like? Yeah, a wavy line of some kind. Could be a sine wave, could be some other kind of wave. You know the rate at which you're moving. You have your time base. You measure this distance. That tells you how much time it took for one cycle. Such a powerful thing. These are related, though. These are optical strip chart recorders. You know what a strip chart recorder is, right? They look like this. They do cardiograms. Bill and I are quite familiar with those. You guys are probably taking lie detector tests. You're familiar with that, right? So, all over the place. But these are optical strip chart recorders. And they can deal with a large number of inputs, whereas the physical ones, they have some limitations. So,